So here we are in part B. I have imported all of the stuff that we had previously, copy and pasted, but we added a few things. We added in numpy.polynomial as P and TF, yeah. Okay, so let's get started with just putting in our polynomial. This is just us working through our transfer function. So we were given some values, and so this is just us writing it down to basically just, it'll show what the polynomial looks like. So we have 1, 3, 5, and 7.2. First one times P, and that's 2, 3, and 4. And so that is what that ends up looking like. That's just our polynomial transfer function. And then we're going to define some stuff. So define our transfer function to our polynomial. And this is going to have the input of TF. And so we don't have to put in anything special. We just need to put in our return, and it's going to be a polynomial of TF dot numerator, and we want the inverse. So we're going to go and then double colon, -1, boom, boom. And then we also have to do, oh, what do you not like about that? We'll figure it out in a moment. So that is TF dot denominator, and then boom, 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 -1. And then delete. Do you not like that? What do you not like about that? Oh, because it doesn't need the parentheses, it just needs the bracket. I'm so used to np.array and then having to, like, you know what I mean. All right, and then shift enter. There's our first one. Cool, that went well. All right, now we gotta define our poly to transfer function. Oop. And so this is also gonna have an input, but this is gonna be our numerator and our denominator. And so this time we're gonna return the transfer function, so TF of the n dot coefficient 1f, and then same thing, inverse, and then d dot coefficient, boom, inverse, shift enter. Looking good. All right, so now we are going to make another formula, and this is going to be our transfer function mult. And so our inputs are TF1 and TF2. And for this one, we are using basically our transfer function to find the numerator and denominator. So N1 D1 is equal to our TF2 poly, so our polynomial of TF1, and then we're going to do the exact same thing, but instead of N1, it'll be N2. D2 is TF2 poly of TF2. All right, and then what we're going to return for this one is we are going to return the poly to transfer function, and that will be of N1 times N2, and then D1 times D2. Shift enter. Okay. So from that, we are just going to check to make sure it's all good. So let's put in what our TF1 is equal to. And so our transfer function, we were given some values, and so this is going to be parentheses. No, not 9, parentheses. And this is going to be 1, 2, and then we're going to do the other one, which is 1, 3, and 4. And that's TF1. TF2 is our transfer function, and this one is 0, and then we have 1, -3, 1. So those are our transfer functions. Okay, but let's just check. So TF mult of TF1, TF2. Shift enter. What is it going to give us? No. You don't like it? What don't you like? Oh, wait. That's a 1. No, still doesn't like it. Okay, I will be completely honest and say I did look because I could not figure out to save my life what it was. It is, these are both polynomials. Let's see how much that switches. Yep, there we go. That took me a hot minute. So there's our transfer function, lay it all out. And so we are going now to use that, and you'll see me write it all out on the whiteboard. All right, so now we're going to oh, sorry, got a notification. Restart. So now we are going to look at our PID controller. And so our PID, this equation is going to be our proportional gain, which will be constant Kc, times our air control, our air signal, sorry. And basically this is going to be with E, and then if we pull this out here, E is equal to our height set point minus height. Okay, so that's what we're plugging in basically for that. And so we have a height set point, find the height. There you go. All right, and then we have it plus 1 over tau is integral from 0 to t. Do I have enough space is the question. I think I can make it work. All right, and so we have our e times dt, and then plus our tau of d, or tau d, over, I'm running out of space, d e? Yes, de. Okay, I made it work. And then, and parentheses. All right, and so what we're going to do for this is we are going to take the Laplace transform. So LPTF, and that is going to be a big capital P, and that is where we're going to have our proportional gain, and it's going to be, let me just write it out. So our proportional gain times 1 plus tau d, tau, no, I'm wrong. Tau is, tau d times e. Okay, cool. And so we can maneuver this all around. And basically what we're going to get is Kc, we got 1, well, all right, so I'm going to get, oh, that is not tau. Tau is plus 1 plus tau d tau is squared all over tau is, and then that is multiplied by e. And so basically this is just for our proportional control, and then let me look at the camera, I have enough space to write this out for you guys. So basically what we're going to do is write in our system. And so let's start with right here. And we're going to make it a block for now because it makes sense in my brain. I don't know. Okay, So we have a flow rate going in, and that is our QC, and we have a flow rate coming out, and that is H1. Okay, and in this, the transfer function in this tank is R1 over A1 R S plus 1. Yes. All right. So we're going to take that, and it's going to go to another tank. And so the next tank is there, and then it's going to go out into another tank. Wow, amazing. All right. So I'm saying tank, but you know, it's just the wait. So blocks. Sorry. All right. And so that is going to be Q2 right there. And then we're going to go down. Well, I don't want it there. We're going to go boop, boom, boom. And that's going to be our H2. And so H2 can also go out here. But we're going to have a stream coming out. And that's basically going to be our measuring device. And so that's going to be 1. And then it's going to continue all the way over. And remember, this is still H2. And it's going to go into the signal Laplace transform. And so it's going to go into here. All right. And then it's going to be E when it comes out. Yeah. It's going to come out E. And then when it comes out, it's going to go into the PID. And then it's basically going to come back into the system as QC. Okay? And so with these two, oh, sorry, I had a piece of hair on my hand. All right, we are going to have 1 over R1. And then over here is our R2 over A2 R S plus 1. All right, and so what we're going to do is we're going to take this and we're going to put it into code. So now we're going to start looking at the one section of our process. So I'm going to go ahead and take out these 2 sections because we got to add some more formulas or functions. So this time we're going to define our P and ID. And this is going to have our inputs of KC. We need our tau I and our tau D. And that is going to go into us returning 3 different values within the transfer function. So TF of our KC times tau I times tau D. That's 1. Second one is KC times tau I. And then the last one is just tau I. Oh, Andrea, stop hitting shift when you don't need to. Delete. Okay. But that tau I, we need to add a 0 into it because otherwise it'll just act as tau I. We don't want that to be the case. It'll get a little finicky for us, so shift enter. Okay, cool. So next we're gonna put in some test values of our P and ID. And so we have 1, 10, and 1. And so when we look at this, oh, no. Why do we not like this? Oh, Andrea, dummy. This is still in the thingy. And then we need just our, oh, stop. I don't want to hover over that. And that shift enter. There we go. Okay, so when we look at this transfer function, this is basically giving us our coefficients. So you can look at it as 1s plus 1s squared plus 0.1. And so that's looking good, and we will continue on to putting it all together. And so we are given some values. So A1 is equal to 1, R1 is equal to 2, A2 is equal to 1, R2 is equal to 2. All right, so those are some of our givens. And basically, we're going to create some more transfer functions because God knows we don't have enough apparently. So QC, and we're going to have that go to Q2, and that is going to be equal to the transfer function. The first one is 1. I need to stop hitting shift. There's 1, comma, and then we have A1 times R1, and then comma 1. And then we are going to do the exact same thing, but instead of it being QC to Q2, this is Q2 to H2. And this is going to be equal to transfer function. We're still going to have that 1 in the beginning. But instead of it being well, I'm sorry, it's not 1 in the beginning. I lied. This is R2. There you go. R2. And this is going to be A2 times R2, comma 1. Shift enter. All right, cool. Nice. And so now we are going to be given a value for KC. KC is 1. We have our tau I, we are given that as 10, and our tau D is also 1. And so those are our givens. And so for this, we are going to go TF mult. I got to be very careful about parentheses here. So we are doing our PID, and we are given our KC, our tau I, and our tau D. And we're going to end our parentheses, and then we do an embedded TF mult, which is where my parentheses, the first time I walked through this, was all kinds of messy. And this is our QC to Q2, and our Q2 to H2. Shift enter. All right, cool. And so now we are going to go back to the whiteboard and talk about the whole process, and then we'll come back here and code that last part. All right, so now we are going to set it up just a little bit differently. So as far as our overall diagram with the transfer functions, we're going to do it with our set point. So H2 SP, and that is going to go into, that is our little plus or minus. So this is with our P and ID that we're looking at. So our PID, which is also, so you can say PID, but what we're actually going to do is we're going to call this our GC. Control, bum bum, and that's one function. There we go. Oops. All right, and then this is going to go into our GP, and it's going to come out, and that is H2, and that's when we bring this guy around, and then we're going to go into our measuring, which is our GM, and that is here, and then it's going to come back out and into that plus or minus. And so when we look at this, we can set up an equation, and so that would be H2 minus our GMH2. Oh wait, no, H2SP, that's right, minus our control H2. And all of that is multiplied by GC, GP, and that is equal to H2. And so what we're going to do is we're going to multiply this out. So we have H2SP, GC, GP, minus GM, H2, GC, GP is equal to H2. And from that, we will move this guy over, and then this stays over here, and then we can divide by our GC, GP. And so basically what we're going to do is we're going to take out our H2, and then goes over there, and so we have 1 minus or plus? Plus our G, M, G, C, G, P is equal to our H2, G, C, G, P. Well, H2SP. Oops. SP. G, C, G, P. All right, and so from there, what we're going to do is basically, because we're looking for this, we're going to divide that over, and we'll pull out our H2SP to make our life a little easier. So our H2 is equal to our H2SP, H2SP, and in parentheses, we have our GC, GP over R1 plus GM, GC. All right, and so, oh, wait, GP. All right, and so basically this is going to be our function for our feedback control. All right, so now with doing the whole thing, we have to go back. I am going to take out, oh wait, no. I don't need to take out anything, I just need to add in. So we're going to add in a section of code right here, and so it's going to be similar to what we have up here, but this is going to be for our feedback. So def of tf underscore feedback, if I can spell, and then our inputs are going to be our tf forward and our tf backwards, and then it is similar to what we have up here. So instead of N1, though, it's going to be NF df is equal to 2F to poly times our TF forward. And then same thing, I'm just going to copy and paste this to make my life easier and just go in here and switch all of these F's to B's. All right, and what we are going to return is NF times DB DF times DB plus NF times NB. Okay, so we have that, and then we're keeping that. What we are going to do, though, is that our tau I and tau D are switching. So this is 0.8. That is 0. And then we are adding in that this is equal to our forward. Beautiful. Okay, and now we're adding in some more new stuff. So now we are going to do, oops, sorry, you can probably hear my neck crack, that was loud. Okay, so now we're going to put in our actual feedback stuff. So TF underscore FB this time, and we're going to put in our TF feedback function that we just made up in the top, and our inputs are going to be our TF forward, and then our transfer function, there we go. And then 1, 1. So we have that, shift enter. Cool. All right, and so now we're going to get ready to graph this. And so we got to put in our t-plots. Got to love our t-plot. All right, np.lin space, and let's go 0 to 100, 500 intervals. Oh, I didn't mean to do that. No. Okay. And then also in here, we got to put in that our t-plot and our h2 is equal to our tf.fb, not .fb, underscore fb, dot step. And then we're going to have t is equal to t-plot. Shift enter. No, what do you not like? Okay, action. Okay, that took me forever. If this is genuinely what it is, I'm going to be kind of frustrated. Yeah. Oh, God. Okay. Well, that took a little too long. All right. So now we are going to do our plotting of this. So I'm just going to go up here and snag this section. I'm just going to do that. All right. So our x is going to be our t-plot. And then our y is going to be our h2. Shift enter. All right, there we are. So that is our graph. And so now, oh, no, let's freeze. No, that's right. Okay. All right, so now we are going to look at simulating the forward transfer function. So down here, what we're going to do is we're going to add in some new stuff. So we're going to put in a tsim, so this is our simulation. That's going to be np.linspace. Oh my gosh, I've been typing for too long. 5,500. Let's do that. All right, and so we are given, so we're going to have W be our frequency because we've used a lot of F's and I have no more F's to give. Sorry, that was a really bad joke. All right, let's just ignore that I said that. All right, frequency is 1, and then E is going to be our controller input, and that is np.cosine of W times tsim. All right, and so we also need to put in our H2 for this situation. And so with this, the way we got to put it into Python for this to work is underscore, comma, H2, comma, underscore. And that is going to be equal to sig.lsim tf underscore forward E and tsim. All right, shift enter. All right, cool. So now what we're going to do is we're going to take what we just did up here, we're going to copy and paste it because it makes our life easier. And we're just going to add in a name really quick. So we're going to name this, oh, not capitalized. We're going to name this one as our output. Okay, and then we are going to copy this again, put it here, and then instead of H2, this is going to be E, and instead of output, it is input. All right, beautiful. There we are.